Okay, still in chapter 6, guys, or unit 6, however you want to think about it. So we are talking about rotations, right? Analyzing rotations right here. This is, turn. Gosh, what's another word for turn or rotate? I'm blanking, guys. It's been a long day. Okay, so anyway, you can think about these as turning, right, around the center point, like probably visualizing a wheel or a Ferris wheel is probably the easiest way to think about what's happening, because there's always a point in the middle around which something rotates. Like, right, your point in the middle, so something rotates around that point. Okay. So Maria boards a car at the bottom of the Ferris wheel. Boom. She rides to the top where the car stops. Maria tells her friend that she completed 1/4 turn before the car stopped. Do you agree with Maria? Explain, and how could you use angle measures to describe the change in the position of the car? Well, clearly she's wrong because she didn't go a quarter. She went a half. A quarter would have been right there, like boom, boom, right there. Okay. But instead, she went halfway around. Okay. So no, she went halfway around, not a quarter of the way around. Okay. And how could you use angle measures to describe the change in position of the car? Well, so we go right here. This is 1/4, half, 1/2. And then if she had gotten to this point, that would be 3/4. Right? And this is 4/4 or 1/2, right? So hold on, guys. Let me pause this real quick. Sorry, guys, sending eligibility forms. Where was I? Okay, so this girl Maria, right? She says she got so that's a quarter, that's a half, that's 3/4, and that's all the way around back to the beginning. So it's either 0 or 1, kind of depending on where or when you're looking at it in the terms of the rotation, right? At the beginning it's 0, but after she's rotated, it's a full whole or 4/4, right? So I could use angle measures to describe the change in position of the car. Well, when we think about angle measures in terms of circles, right? And hopefully you are cognizant of this or aware of this, but like we measure circles in terms of 360 degrees around. Okay, so 360 degrees around is a circle, right? So that's kind of how we break it down. So if we think about calculator, if we think about these measurements in terms of that 360 degrees, we can break it down by saying, well, 360 degrees, right, a quarter of that, right? So what's 360 degrees times a quarter? I'm just going to say multiplied by 0.25, which that's quarter, right? So that's 90 degrees, okay? Okay. And so then if we think about it in terms of 360 times a half or 0.5, that's 180. Okay. And then 360 times 3/4 or 0.75, right, is going to give us 270. And then 360 divided by 360 is 1, right? So this is 1 or 360 degrees right there. So that's kind of how you measure things in terms of angle measures, right? So you divide 360 into quadrants, right? Kind of dividing it 4 times to get to how far you go around. So divide 360 into quadrants. This one's 90 degrees, that's 180, 270, and then 360. Okay, and that's kind of how we talk in terms of these rotations, right? We talk about it in terms of the degree around the circle, right? But in reality, right, 90 degrees is a quarter turn, 180 degrees is a half turn, 270 is a 3/4 of a turn, and then 360 is a full turn going back to the beginning. So setting it up, we talk about these in terms of degrees. Okay. Okay. So understand rotations. One feature of the new patio plan is a rectangular umbrella that can easily rotate so that clients can enjoy either the sun or the shade. How should the architect rotate the umbrella to highlight the features for his clients? Okay. Then I had to like parse this a little bit. This side with kind of like the dash with like the stripes on it, that's where they let the sun through, and then this one where it's kind of blocked off, that's where the sun is blocked. So how should the architect rotate the umbrella to highlight this feature for his clients? Give me a sec, guys. Here. Okay, if we kind of imagine, let me get back to my camera. Sorry, guys. I don't want to open it with Excel. Okay, so if we imagine that the sun is kind of over here, so let's go to a little sun, like shooting its rays this way, right? Well, this side isn't really going to help it, okay? Because we want this side's going to let the sun through, and this side's going to completely block it. So the idea is we want to kind of rotate it like this way to let the sun through, or this way, so it kind of like brings this side around to completely block it. So we only have to rotate it a quarter of a turn, right? So that's a quarter of a turn is 90 degrees, right? So and then you just figure out whether you're doing it clockwise or counterclockwise. Clockwise follows the direction that a clock goes. Counterclockwise, is opposite the direction of the clock. Okay, so let's kind of write that in here, right? Because that's the vocabulary we're going to be using. Okay, this is clockwise. Okay, clockwise. I know it looks like a D. Sorry, and the other direction is counterclockwise. Okay, the opposite the direction of the clock. The architect continues to rotate the umbrella in a counterclockwise direction until it is in its original position. Good work, Wishart. Position, sorry. What is the angle of this rotation? Well, if we kind of just rotate it all the way around back to the original, right, original position, right? We talked about this a little bit. That's 360 degrees, which doesn't really do anything to change it, right? It just returns it to its original position. Okay. So yeah, a full rotation all the way around is 360 degrees. So that's kind of the idea here. Okay, what are the coordinates of the image of trapezoid ABCD as a 90-degree counterclockwise rotation about the origin? When it says about the origin, this is the origin right here. This is called the center of rotation. Okay, there's always something that it rotates around, right? In the case of like a tire, it's rotating around the axle, but a lot of this is rotating around the origin. In fact, that's all we're going to talk about in 8th grade. You'll rotate around different points when you're in geometry, so just be aware. So we're going to do a 90-degree counterclockwise around the orientation. So basically, it's moving from this quadrant to this quadrant right here. So we're going over here. Now, this is quadrant 1. This is quadrant 2. One thing I want you guys to start internalizing is that your x and y are positive over here, both positive, and in this one, your x is negative. You can see they're negative here, and your y is positive. So negative for your x's, positive for your y's, okay? So when you're rotating like this, we use this kind of table right here, okay? If you're starting in quadrant 1, okay? Let's be very clear about that, okay? Because you can start in different quadrants, okay? Okay, so if you have a 90-degree rotation, what happens is you take your x and your y, you flip them around, and you make the first number after that change sign. So if it's positive, it becomes negative. If it's negative, it becomes positive, okay? So the trick here is to know the coordinates of each of these points, right? So I'm going to say that I'm going to just write A, B, C, D. So A is 2, 3. Okay. B is 4, 3. C is 5, 1, actually. And D is 1, 1. Okay. And so what we do is we take this rule and apply it to each of these points. So what we're going to do is we're going to flip each of them, and then we're going to make the first number negative. So A prime becomes negative 3, 2 after we flip it and make the first one negative. B prime becomes negative 3, 4. C prime becomes negative 1, 5. And D prime becomes, they flip, right? And you make the first one negative, so negative 1, 1. Okay? And so you can see that what we've done is we made the first one negative, the second one positive, which is what we want, because we know, since it's just going to rotating 1/4 of a turn, that our shape is going to be in quadrant 2, and our x's are negative and our y's are positive. Okay, so now we graph them. Negative 3, 2, start at the origin, go left 3 up 2. That's going to be a prime. Let's see, where do I want to put my... Boom. Okay, b prime is negative 3, 4, so over 3 and up 4. Okay, c prime is negative 1, 5, so over 1, up 5. And then d prime is negative 1, 1, so right there. Okay, and now use your ruler. To connect your dots. Okay, and you can see that it looks like it's like kind of like moved up, right, like that, around that center point, right? So just like that. Okay, and you can keep rotating it into quadrant 3 and then quadrant 4 if you wanted to, but it's only asking us to do one 90-degree rotation, right? So that's a 90-degree rotation. If we were going to do a 180, all that would happen is we would keep the numbers in the same spot, and we would just change the sign for both of them, so they'd both become negative for each one. And if we did a 270, which means it would go 1, 2, and then end up in quadrant 4 down here, you flip them again, but instead of making the first one negative, you make the second one negative. So that's how these work, right? Those are your rules. Okay, there are other ways to do this, but it involves like transparent paper and things like that. So using the rules, I don't know, it's probably easier. I don't know. Okay, describe a rotation. So, I don't think I actually got the right. Dang it, Dave. Okay, I'm going to fix this for the actual one that I print out. So let me actually pause for a second and see where this is supposed to be. Okay, guys, sorry about that. I will fix that for when I print this for class. Okay, so this is what it should look like. So describe what happens, right? So a couple ways you can do this, actually. So we know that this is the original because it doesn't have prime notation, and we know this is the original because it does have prime notation. So you can think about it as happening one of two different ways. You can think about it as happening going kind of one quadrant that way. So it's a quarter turn that way, so that it's 90 degrees clockwise if it goes that way. Okay? Because remember, each quadrant that it moves gives you another 90 degrees. Okay? So this is moving one quadrant, so that's worth 90 degrees. That's a quarter of a turn, right? If we kind of refer back to this, 1/4 turn is 90 degrees. Okay? Now, if we go the other way, right? If we start here and we go all the way around right here, then we go 1 quadrant, 2 quadrants, three quadrants. That's a 270 degree counterclockwise rotation. Right? Sorry. So like 1, 2, 3 quadrants. That's 270 because 90 times 3 is 270. Right? So 3/4 of a turn is 270. Okay. So that's a 270 degree clockwise rotation. Okay. So yeah, you could say either one of those things. Another thing you could do is you could go from the origin, and you could draw just a line, we'll call this a ray, out through one of the points, right? We'll just go through A, and then we'll go through that matching point for A prime. Okay, so you can see that this is a 90 degree turn right there, so that's a 90 degree rotation. So kind of two ways to think about that, okay? So yeah, that's the rule that happened kind of after the fact. And we're going to put this in our notebook. This is going to go on like page 51, I believe. Yeah. And then I'll put the table of contents together real quick. Okay, 51, 6, 3, analyze rotations. Okay. That's that, guys.